I'm back.
Can see you.
Yeah, but I'm still not able to join using the app. So I'm in
Right.
the browser. Yeah. Which is fine.
Okay, fine.
Yeah. That,
Sadly, I think there are people connected, so everyone could hear us.
okay.
Um,
I
what we're going to do is we'll wait for another 5 minutes. I
All
mean,
right.
can stay. So I'll join in 5 minutes, and then I would have the intro, welcome you, and then you can start off. Then we will have some time for question and answers.
Cool.
So maybe you can ask.
I can't see the sharing though. The desktop sharing. Where
Are
could
you
that be?
using a browser?
Yeah.
Hold on. Uh,
Maybe
Let
you
me
have
do it.
to allow me or
Yeah,
something.
yeah, yeah. Hold on. Let me. You don't see an option?
I can't see. Hang on. Oh, okay, okay. All right. Yeah, I can see it now. I think I have to enable something. All right. Okay. Okay. I'll have to rejoin.
Sure, no problem.
Okay.
Okay.
Okay. Thanks. All good now. Yeah.
Good afternoon, guys, and welcome back to our National Cybersecurity Week 2020. This is the second day, second session. We've had a lovely session this morning, and now what we have is on malicious activities observed in distributed honeypots. We've got a well-known speaker in this industry who does not need an introduction for himself. We all know him very well, Adli Wahid, Senior Internet Security Specialist at APEN. He's currently engaged with APNIC members, LEA community, certs, and etc. He's mainly involved with Honeypot project, running the backend and collaborating with partners. So that's a big thing. Building threat sharing community in the AP region, Asia Pacific region. To tell more about Adli, he's a member of a board of directors at First Org. Then he was a manager at Bank of Tokyo Mitsubishi in the past. He was Vice President, Cybersecurity Response Service of Cybersecurity Malaysia. He was a Senior Specialist and Head of Malaysia CERT back in days. And at the moment, he's connected to APEN as a Senior Internet Specialist. So with that, let me welcome Adli Wahid. Adli, over to you.
Thank you, Daya. How's everyone doing over there? Hopefully everyone is doing well. Thank you for the generous and kind introduction. And I would also like to appreciate or show my gratitude to the organizers, friends at the Sri Lanka CERT, for always thinking about us, inviting us to your event. I'm very sad that I'm not able to be with you guys physically, but you know how things are these days. It's hard for us to travel. Thank goodness we have the internet, although I will be sharing some depressing view of the internet today in my presentation. So as you can see, the title of my presentation is Malicious Activities Observed in Distributed Honeypots. I've been to one of the conferences before, I think maybe a couple of years ago, where I spoke about honeypots as well. This will be slightly different. It'll be focusing more on things that we see on our distributed HoneyNet infrastructure. You can find me on LinkedIn. So perhaps, since we are not able to connect with one another physically, see each other in person, LinkedIn is probably the next best thing. If there's anything that you find in the presentation that might interest you, or you have maybe further inquiries, or you want to give feedback, feel free to reach out to me on email. And once in a while I tweet, but you can contact me there as well if you would like to. So yeah, let's connect. All right, what will I be talking about today? I know I got about an hour or so. The plan is to start with a little bit on the APEN Community HoneyNet project, why we started it, what was the purpose, how it works, basically, especially with regards to our members and stakeholders. Next, I'm going to be spending most of the time on the HoneyNet project, as well as things that we have observed. And I plan to go deep into or go right into the activities we're seeing, the malicious activities, focusing more on attacks on IoTs or Linux servers, which I think may not receive the same attention as attacks on Windows systems or malware on Windows systems these days. But something that we have to probably think about or start looking at, and from there maybe we can have some discussions on maybe detection, threat sharing, analysis, and so on and so forth. So I keep that quite open so we can have perhaps some discussion back and forth. And And I thought maybe it would be of interest as well to talk a bit about deploying your own honeypots. Just taking our experience and then maybe sharing with you, if you would like to deploy honeypots on your own, what are the things to consider? What are the top 5 things to think about or to consider? And then maybe that will lead into maybe further discussion about tools and techniques and things like that. All right. So I am quite new to WebEx actually. If you have any questions, just put them in the chat box, or I'm not sure how the moderator will manage it, but feel free to just I guess type your questions, and then maybe in the middle or towards the end, if I figure out how to see the chat box from the screen, I can answer them as we go along. But otherwise, I'm happy to just maybe wait until the end and take up the questions then. And hang on a sec, I'm just gonna see the time. All right, so let's move on. So the first is the APEN Community Honeynet project. I'm not sure how many of you have heard about it, but we do write about it quite regularly in our blog. So APEN has a blog, blog.apenic.net. There's some articles there from time to time we publish and share. And basically the context of the Honeynet project when we started it was more educational, because we had this training that we do, the network security training at our conferences. And as you all know, the majority of people who attend our meetings are the network operators types, the ISPs, right? So they are network engineers and doing networking for the organization, but perhaps they haven't really seen an actual attack taking place, right? In a lot of cases, network operators or people managing networks or enterprises, they are at the receiving end. They get attacks, right? So they are waiting for this attack to happen. But looking at the Honeynet data, you can start thinking about what happens before the attack. Prior to the attack, how does attacker work? What do they do? How do they build their own infrastructure to then launch a big attack against an operator, for instance? So running the honeypots, we were able to kind of show that and also demonstrate things like malware. How does malware works? What is a dropper, for example? What does a malware do when it runs on a system? So it was educational and researchy, I guess. Of course, we didn't do much on the research side of things, but it provides some situational awareness as well. That hey, maybe there's something on your network, and also there are techniques that we can do for increasing detection, right? And from there, talk about the bigger picture, cooperation, policy. If I have an infected machine in my network as an operator, and these guys, keep on getting infected and trying to infect other machines, right? They brute force other systems. They scan other machines on the internet. What can you do as an operator, right? In a lot of cases, they will say, "Oh, there's nothing we can do. We're not the police." Yeah, still, you'll get complaints. People will report abuse to you. Eventually, you have to do something. You have to have a policy, right? Because when you have a policy, then you can talk to the customers. And then, maybe you can negotiate and then manage it from there, fix something. Anyhow, so I think so the Honeynet project encourages discussion around this topic. Whether or not it changed people, I don't know. But at least we have some real data to talk about, and we can show to folks. What is also interesting with the Honeynet data, then we can actually show other tools that are of interest or that are used widely in other communities, like MISP, for threat sharing. Now you have all this data about threats. Do you just sit on it if it involves other people's network, or can you actually share that with others? And what is the best way to share, right? And how do you create a community for sharing things like that? So tools that we can use for doing analysis. Some people are like, oh, we want to do some reverse engineering. What tools do we use now that we have binaries and stuff like that? So initially it was for educational purposes, and I thought it was very, very useful, especially to show folks, this is what it looks like in an attack, how attacks are being carried out, so we can easily show that. So it's not just theory that, hey, attack is coming your way, be careful, do this and that. The other goal that we have was collaboration. So we wanted to run a distributed Honeynet project where we wanted honeypots in different places, right? So the best way is collaboration, but collaboration is not one way where, hey, deploy a honeypot for us and we'll take all the data. But we also wanted to basically use this collaboration to strengthen one another as well. So as people join in, they not only get data about their network, but they also get to learn as we go along, right? Because we are just facilitator, right? We manage the back end, we basically drive the project, but at the same time, we want everybody to kind of benefit from this in terms of learning, in terms of experimenting. So we have some good success stories as well. Maybe I'll share towards the end. But we were thinking also, now that we have some data, then how can we actually get this data out there to different organizations, different stakeholders like the certs and so on. So that was the bit, the collaboration bit that we had in mind when running the project. The last bit is the outcome itself, right? So what do we have? So we've been running this since 2017 officially. I started a small version of the HoneyNet project when I joined APEN in 2014. And maybe some friends at Sri Lanka Cert knew me beforehand, and I've been doing Honeypot since my days at the National Cert, maybe 2007, 2006. Yeah. So been doing this for a long time. But now for our own project, we have about, I would say, 50 to 70, because there are honeypots that we turn on and off occasionally, and we swap them around as well to avoid, attackers fingerprinting them and then, throwing a lot of junk at us, stuff like that. We started, some threat sharing information services for APEN members. So there is a product now called Dash, where people get a high-level view of what's malicious or what's suspicious coming from their ASN. And all this data came from the honeypot. So instead of showing them the raw data, we kind of simplify it, just give them some, very nice picture. And they have the option of getting insights, like asking, what is this exactly? Can you explain to me? So we found that quite beneficial in terms of, getting people the awareness and then taking things kind of slowly and not push a concept down people's throat. And if you're interested to learn more, like I said, we blog about this quite a bit, and check out the blog for some additional information. Anyhow, you're going to see a lot of that here. Anyhow, so in a nutshell, right, this is the fancy diagram. Some of you may have seen this before. The idea of the HoneyNet project is that we kind of manage the back end, right, using open source tools, and we invest a little bit in this on the services hosting. We do host our own honeypots in different places, but also we have a lot of partners, right? Most of them are ISPs, but we also have law enforcement agencies, some certs, deploying the honeypots and then accessing the back end, maybe to have a look or to analyze it, to learn more, and so on. And we try to develop the community in terms of education, training, and so on. This is just a screenshot of the dashboard. For those of you who are familiar with Elasticsearch, you can tell right away this is Kibana, right? So nothing really interesting there. I mean, in terms of the tool itself, but this is data from the last 7 days. I'm not sure where that went. I thought I had a title there somewhere. So last 7 days, you can see a lot of hits on the honeypots. I'll talk more about what inside the honeypots and what this all mean, right? Because otherwise, it's just a fancy graph of something. So a lot of traffic are hitting the honeypots, which in itself shouldn't be the case, right? If you really think about it, the honeypot doesn't contain anything that people want, right? There's no service or services running there. And by right, I should not be seeing any traffic. Maybe a lot of scanners, like people who are scanning systems like Shodan and Census, they scan the whole internet to map the internet and to see what's running, and then they maybe sell a service. So you should get that, but I should not be getting anything more than just, I guess, port scan. But in a lot of cases, all this connection are active connection where we simulate some logins and people actually try to log in. And then when we try to let them log in, they do things on the honeypot, so we can actually see the commands that they run and so on and so forth. So that's a screenshot. And this is the bit where you can actually see, the URL of where malware is being downloaded. So someone or an attacker or a bot goes into the honeypot and then issue a lot of commands, including, trying to download some binaries or a script to run on the host itself, right? So we get to see a lot of that as well. And this is the bit where you start thinking about information sharing. Like, as it is, I don't have any need for this, but there might be some people who can benefit from this information in terms of maybe taking down those malicious links or binaries, or do a full investigation on the binaries itself. And if you think about it, maybe for some folks, some of this information could be turned into a block list, right? So that if any traffic from your own organization is trying to reach any of these URLs, then that's, that should raise an alarm. Down here, this is basically a cloud, what did they call it? Cloud word? Yeah, this, of username and password that we see being attempted. It's not really 100% accurate here, but basically the idea here, this is a bunch of username and passwords that we see on our honeypots. Again, nothing really fancy here, but I think you get the idea. From the data from the collected from the honeypots, I can also not only see what's happening on the honeypots, but I can then, look at, for example, a country view. Show me all of the traffic, all of the network traffic from Sri Lanka IP space, for example, or this particular AS number. The idea there was, when we have all these logs, then we can actually start parsing them, right? Analyzing them, and then break it down into a perspective that we are interested in, right? So maybe at APEN level, we are not interested to see what each country is doing to our honeypots or economies, but for the certs or from the AS, operators, they might be interested in very specific data, right? And this can then be used in other forms, not just as a presentation, as a visualization, but maybe something that is more practical, like an alert that comes through email or a ticketing system, right? So the idea here is that not to just look at the dashboard, because nobody really look at dashboard all day long. If you're a security practitioner, this will then tie into an alerting system, like maybe you use Slack or you use a proper ticketing system for handling incidents, and so on and so forth. All right, so and again, this is not to single out Sri Lanka, but I thought maybe, since I'm talking to an event in Sri Lanka, I just pull out this data just to highlight that we do see some traffic from Sri Lanka. Cool. Now, the next section of my presentation is, let's go a bit deeper into the malicious activities that we're seeing on the honeypot, right? So a honeypot that we use is to attract certain kind of activities or certain kind of attacks or threats. So what I'm trying to say is that we don't see all kind of threats, right? We don't see all kinds of attacks, and we cannot see an attack, certain kind of attacks in action as well, right? So let me give you an example. I remember giving a presentation at one of our conference, and a few network operators came to me afterward and say, can you see a DDoS in action in the honeypots, right? We can't, because we are not in the path of that attack, right? But we may be able to see the recruitment process of the botnet, right? Where it's trying to recruit as many hosts as possible, which then later on at some stage will be used for a DDoS attack. So that's one thing. And some folks have asked me as well, what about APTs, the advanced persistent threat? Are you able to see in your honeypots? At the moment, no, right? And it's because the honeypots that we run, there might be some honeypots where you can actually set up to maybe, trap an APT. And this might be something that you deploy inside the organization. Our honeypots are on the internet, and they simulate generic services like a telnet and SSH. Most likely, the APT actors will not be targeting honeypots or telnet to launch their attack. The technique they use is something else, maybe first through email, or trying to find out services that are accessible on the internet, like a web application, which we don't run in our honeypots. So you will not be able to capture all kinds of attack. But having said that, if you think of what kind of attacks you want, then run the right honeypots. Maybe you can pick up those things. Now, going back to my story here, so we run a bunch of honeypots that mimics Telnet and SSH, right? And this is relevant to this discussion because we tend to attract a lot of the Linux and Unix malware, right? And this gets interesting because when you talk about Linux or Unix malware, then you see a category of targets that is really interesting, which are the IoTs, right? The Internet of Things, or in simple terms, the routers, the modems at home, the ADSL routers, right? The servers that you run to host your web application or your email server or your FTP if you are still using FTP. So we see a lot of attacks targeting this type of devices or infrastructure, right? Which is interesting, right? Again, this is not new, right? And it also debunked the myth that there is no malware for Linux or Unix, right? So I think maybe 10 years ago, people used to say, oh, you know, if you don't want to get infected with malware, use Linux or use Mac OS. Yeah, not so true. There's a lot of malware on this, infrastructure or operating system. So it's not new, but it's quite pervasive. And we see this a lot. Like I said, if you saw the stats before, we shouldn't be seeing any of that, but we're seeing it. And talking about Telnet, right? Those of you who are in the industry for a long time, you know, at some point we thought Telnet was dead, right? And it was replaced by SSH. Not so, right? There's a lot of new and emerging, right? Next generation IoT devices will Telnet enable, which is really bad, right? Because it means that, you know, in a lot of cases, a lot of these devices, well, it's another surface for someone to get into a device or a system. And number two, we see in a lot of cases that they are weakly configured, or just with the default username password, and can easily be brute forced, unfortunately. So the other bit that is quite interesting in terms of the target for such malware or attack is that in a lot of cases these devices are unpatched and unmonitored, and this is quite interesting because things that we own, like computers or laptops or phones, we really make sure that we patch them on time, right? We get very paranoid about patching, and we get alerts, right? And in a lot of cases these days, we will be notified, or there is an option for doing automatic updates. But for some of these devices that we see that are exposed on the internet or in the network, they don't have these features, right? They sometimes cannot be patched, right? And they cannot be secured as easily as we would like them to be, right? It's like there is there is a distinction that we somehow made when doing security, that the only thing that needs to be secure are the things that we kind of use or see a lot, but not the things that we just configure and set up and just leave them running. Somehow that that got into industry. So default weak credential is a thing, and it's really worrying if you look at the honeypots data. Now, when talking about Unix malware, we can see the ultimate goals of this malware, right? Of course, you have the APTs and all that, but the thing that we see a lot are just the DDoS agent, right? So the idea is basically to infect a device and then use it to launch a DDoS attack in the future, right? And it kind of started to happen a lot more when the Mirai source code was shared publicly, right? So Mirai, perhaps you have heard, the legendary DDoS botnet and malware. It caused a lot of damage, I think, in 2016. And as people were investigating it, the author of Mirai decided to publish a source code, and as a result, there's a lot of variants that use the original source, and from there, the authors tried to infect as many computers as possible. So I'm not going to go deep into that, but if you're interested, there's a lot of interesting talks and write-ups on this already. But I thought I put some keywords there. You can see, that there are many variants. People just modify a couple of things. Joshua, Owari, Sora. We see this in the honeypots as well, because sometimes they name their binary with the name of the variants that they just, give a new name. And there is a GEF guide as well that is quite famous. A lot of publication on this by many of the AVs, antivirus companies who are researching this. So the technique is so simple, right? For infection and spreading, right? Brute force, SSH, or in some cases we have seen as well where they try to exploit the web application running on the device if it's exposed, because normally some of the devices, the only way to manage it is through a web interface, and they contain some vulnerabilities, right? The OWASP top 20 that you may be aware of. Some of the devices do have those vulnerabilities, like local filing, remote file inclusion, and things like that. So the ease of infection and the prevalent is kind of scary. I think if you're in security for a while, you are then puzzled, like, why haven't we, why can't we fix this? Why is this still a thing? Why do I have to deal with this, right? It's kind of scary. So maybe, something people in the industry like us who are attending conferences should discuss, like, how do we put a stop to this once and for all, right? Before the next conference. Anyhow, I think this is becoming more worrying, because now with the pandemic that a lot of us are working from home. And you can imagine the traditional security perspective that we have is come to the office and you are secure, right? Because we defend you at the perimeter. So anything in our network that we have, we have visibility. We have policies that we can make to be applied because people come and work at the office. Now at home, I wonder if that is still applicable, right? Or if people actually do that, right? If they allow staff to work from home, do they then make sure that things at home are safe and secure and not infected, like the routers or whatever devices that they have at home? Because if not, then potentially stuff that you're working on from the machine, if you don't have any of the other security controls like VPN and things like that, your information or data might be at risk because of now that you have this exposure of people working from home. Next is also, a lot of folks are working with servers, and there are normally, things that you can just create on the fly, especially with, with Docker and with VPS and things like that. So they tend to become a target as well, because I think the ease of doing development work now on servers, has made it, too easy that sometimes people forget to secure things. And I've come across this quite a bit just looking at the HoneyNet data when I report something to someone and they're like, oh, someone was working on that yesterday, and that's why it had a default password on it still. And I was like, maybe, if it's on the internet, you should not have exposed it. You should have make sure that it's secure first, before someone approve this server to be put online, right? Because now it's hacked already. But people are like, oh, don't worry about that. It's just development. So something is not right in terms of the workflow there on how to get a server up and running on the internet and, and getting them exposed. And the Linux malware story is Linux malware is taking advantage of these things that we don't really take care of. So I was talking earlier about, DDoS, right? And at our own conferences, people love to talk about DDoS, but like I said, they are talking about it from the receiving end. Hey, we are hit by a DDoS attack. How do I recover quickly, right? But what they don't want to talk too much about is, what happens before the DDoS attack, right? How does an attacker gain access to so many systems around the globe and use misconfigured services to launch this attack? Right. So instead of fixing the root cause, you're talking about defending when you are in trouble, right? Which is okay, but really, if you want to make sure the problem go away permanently, you have to really address the root cause. And I think this is on every security practitioners in this room, in the audience, in the world, right? Don't just focus on the problem when it's happening, but before the problem emerges, we should try to fix them as much as possible. Now, there's a lot of work being done with regards to DDoS attack. And I think, speaking of DDoS, one thing that came up couple of years ago is the amplification attack or reflection attack, where to launch a DDoS attack, you don't really need to own, well, you need to own a lot of bots in your infrastructure, but there are services that are legit that you can take advantage of if they are misconfigured. And this is the DNS, the NTPs, the SSDPs, right? And they are abused and used for a lot of the attacks. However, a lot have been said about this already, and a lot of work has been done. I mentioned here CyberGreen. They do a lot of threat sharing on IP addresses or AS number that has a lot of open NTPs or open DNS. And in a lot of cases, a lot of the devices are at home, right, on the customer's premise. I mean, at least that's the excuse a lot of the ISPs or network operators use when you say, you know, how come you're not fixing that? Oh, it's not, you know, it's customer's premise. But still, you know, these are the thing that makes a DDoS attack quite simple to execute, right? And as we can see, you know, there's a lot of the stressors or booter services operated by the cyber criminal underground, right? So DDoS as a service. If you don't like someone or an organization, you can just pay them money, and then they will do the work for you. So there's a mismatch between what we care about DDoS and what we don't care about DDoS, right? And it seems that we care when we are attacked, but we don't care if there are hosts in our network that are used by, you know, the cyber criminals to launch DDoS on other people's network, right? Why? Because maybe we're not feeling the attack, so it's not our problem. Or someone have notified you about the problem, but it's like, you know, it's hard to fix, so I'm just going to ignore it for now. So I think that's kind of the irony of this whole story sometimes. So there's active bot recruitment, and we see this a lot, right, from the honeypot. So and it's because, you know, the exposed services that we see, the vulnerable devices, the IoTs especially, and also the service, and weak credentials, username and password, right, that people tend to not secure, unfortunately, and they don't use even things like multi-factor authentication on some of these services. Okay, so the recruitment process is quite straightforward. A source, right, an existing bot or a spreader, you know, a super spreader, will scan the internet to look for some of these services. Right? It could be telnet, it could be SSH, it could be web application, as you can see. And then if it finds a telnet port open or SSH port open, try to log in, right? With default passwords, with easy password or a collection of password that they have come across. Admin 123, root 123. You'd be surprised that this still works today, right? In 2020, when we do all this promotion about, you know, hardening password, you know, securing password, this is still happening, you know, every single time. So something is not right somewhere. There is also, you know, things like this at the bottom here, where it's remote code execution via the web interface of the device itself, where it will allow the source to gain access to a shell and then execute some script and download a shell and execute it on the host. You can see here, remove it, and then now the code is running. And the idea is that when the code is running, once they have access to the device or the server, then it will connect to a command and control, and then just wait for further instruction, right? Simple technique. But like I said, it's quite prevalent. So I mentioned this earlier, so I'm not going to talk too much about it, except for, yeah, so the other thing that I will talk about, other than just the DDoS agent, right, are the crypto miners. So this is quite happening as well. A lot of the machines, especially if it's a server, are being compromised to run crypto miners, right? So attackers will just make money from you, from your resources. So the honeypot that we use, the honeypot that I will be discussing, we have different kinds of honeypots, but the one that I'll be discussing today is the telnet and SSH honeypot. So it's called Cowrie. It's open source, and you can actually write your own, right? But Cowrie is quite interesting because, like I said earlier, not only it will fake or emulate the service, it will also allow or entertain, you know, the connection by issuing a fake shell and then recording the transaction or the activities and capturing the downloaded file on disk for our analysis. So that's the interesting bit about Cowrie and why we use it. Just to show you what's interesting here is, if you look, this is a new honeypot that we deployed somewhere. I forgot where did we deploy this. Anyhow, that's not important. But as you can see, right, if you look at the timestamp, they are quite close to one another. 1931, right, 1931. From two different IP addresses, right? So 123 blah 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 .12 80 something something .62, but the username is the same, right? And the password is the same. So if you look at this, these are two different sessions happening right up after one another on a freshly installed honeypot. What can you say about this attack, right? So two different sources discovering the same honeypot, or what they may think a device, right? And using exactly the same credential to log in. Of course, the honeypot allow this connection to come in, right? But the fact that it is using the same username and password basically is a telltale that, hey, this could be the same class of infected machine or botnet, right? Because so upon infection, upon getting infected, other than just waiting for the instruction to maybe launch a DDoS attack or whatever, scan other machines on the internet, right, and try to get to recruit more into our botnet, right? So that's quite telling if you see there. And of course, once they get into the device, these are some of the commands that we get to see. In this case, I did not hide the IP address, so don't go there. I don't know if it's still running or not, but you can see that it's Mirai, or the binary is called Mirai, and it gets executed. wget gets executed on the machine, and then change mode executed and then removed, right? But there is more, right? There is more commands that we can see. These are from different transactions or different network events. First one, IP table stop, stop the firewall basically. Here in this case, create an SSH key, right? This could probably be used to access some other system for doing other things, right? Change the password on the device. The last one here, I was told that this is related to MikroTik, right? Back in, I think about a year ago, there was an operation by Interpol and some law enforcement agency of crypto mining activities that targeted MikroTik devices, right? So someone was telling me that if you see something like this in the honeypots, it means that the connecting device could be a MikroTik, a compromised MikroTik device. I did not investigate further, but I did a bit of a read up, and that seems to make sense, right? But it's not just binaries that they download. A binary is a compiled. I'm talking about compiled file that can be executed on a host, where you don't get to see the source code. But there's a lot of instances where plain text scripts, right, like a Perl script, are being downloaded on the honeypots, right? Or what the attacker would think, or the bot would think, an IoT devices or Linux-based IoT devices, which probably have a Perl compiler or Perl interpreter running on it, and you can actually see the details, right, without having to execute the script or what this is doing. First of all, you can see, that the command and control information is right there, the port number, the channel that it's gonna connect to, the admin, where I guess it will take instructions from, and of course, we know the location. And if you look down here, where does it say? All right, I think maybe in the next one, in terms of the function itself, right? So this script has nothing but, DDoS functionality, right? So you do UDP, TCP base, HTTP, flood. There are also some other stuff. I see mail here. It's probably for spamming. Port scan, right? And I think if those of you who are been doing the work, this kind of work, incident response for a while now, this is not a mystery. We used to see this a lot back in the days, and the thing is, we're still seeing it now. So this hasn't gone away, right? And you can see here also, this is the source code of one of the binaries. And you can see in terms of the functionality or the commands that the infected host will be getting are the following, right? Can install stuff, update. There's a functionality for updating the program that was installed on the host itself, fast locks, and run bash, whatever. So you can actually see the command. So there's a lot of research around this work as well, which basically shows that there is confirmed malicious activities that we actually see. So one thing I want to talk about also is around earlier this year, about February, there was an article by Malware Must Die. So these are a group of malware researchers. They do a lot of interesting work, particularly in the Linux or Unix malware domain. So they post something about this, and I see that activity as well on our honeypots, right? And the bit that I wanted to show you here is that so this IP address, so there's two source that is trying to infect the honeypot, and they all will then point to downloading the malware from the same host, right? So 5.288 here, and you can see as well that they use different password combination. So root juantag and root hipc 3518. So one thing that you can think about of where they get all these credentials are probably also from systems that they have compromised, and then try that on new targets, right, to increase the possibility of getting in. And so where the actual malware is being served is just one location. The source of the attack is from different locations. So this again highlight what we saw previously. But speaking of FBOT, there were a lot of FBOT activities in our region, in Asia Pacific region. So there were a lot of countries here that had this kind of infection, but then it went away all of a sudden, right? So there was a lot of activities as well. Like, so before that, so it went quiet for a bit, and then in May, came back, went quiet for a while, and then in July, right, it became active, and then it died down, right? So you can see also the campaigns that are being done. So sometimes the idea here is that the machines that are being infected, right, they may not be active all the time, but they are there to serve a particular purpose when people are interested, or the attacker are interested to know more. Right, so I'm just going to go next to the cryptojacking very quickly. So other than just DDoS or recruitment, botnet recruitment for launching DDoS attack, we see a lot of crypto miners as well. This is an example. We see a lot of this at the end of last year, 2019. I've spoken about this in many other conferences. So if you email me after this, I may be able to give specific presentation just on this. And what was really interesting in this particular one was that instead of downloading a binary, it was a script that was posted on a website, right? Which then led to downloading of a few other files that looked like a PNG or JPEG, but basically they are malware. And there's some checking here, normally checking for if there was an infection before, and check on the architecture, and then downloading the right binary. But then if you do a bit more analysis, right, that so-called image file and whatnot, we can find that it is actually malware. It's CoinMiner. So I'm just fast forwarding some basic analysis here using VirusTotal. Again, it's a well-known thing. Like when we check it, it was already in the wild. It was already very active. So not a surprise there, but coin mining activity. So this is basically another one that we see quite a bit. There's a lot of interesting write-up about such groups. One popular one is the RockGang or RockGang. you may find a lot of these activities as well. This screenshot here is actually from a real server that was compromised. It was a web server hosting a bunch of websites. And I thought of just showing you here because we saw certain indicators that we saw in the honeypots that is quite similar to what was seen on the infected server itself. So there was a web shell, basically, right? Looking at the traffic and also the processes running. Processes running. We can see that there's a lot of there's some programs run that then will connect to the pool miner, right, where the results of the calculation is being sent. And if you scan the program, it's obviously malware. So the idea of sharing you here is that people are aware of ransomware and so on and so forth, but there is also another alternative which is kind of noisy because this is active process running on a host with visible network activities. And still, sometimes administrators or network engineers miss this. And I guess the reason is because you're not looking for it, right? You might be thinking about ransomware or malware, or you're predicting attack will come through email, so you focus all your efforts there. But there's a lot of things that maybe not in your radar because you haven't seen it in real life, so you're not thinking about it and you're not actively seeking it. That, or in this instance, the administrator said that, well, he never really look at the logs or the net flow. It's there, but they don't really look at it. Maybe because it's a lot, it's not automated, right? So even if it's automated, you really have to know what you're looking for before you can actually automate something. So I guess that's something that we have to really think about. All these activities, we're not seeing it. Is it because we're not looking for it, or it's not there? So that's a question for you, right? And for myself. Now, quickly before I end this presentation, what if you're interested to run a honeypot? I think you should consider running a honeypot as one of the security controls in your organization. And the reason being is for detection, right? It can be useful, right? And because it's so cheap and easy to deploy, I think it's, even if you don't detect anything, it still can be useful, right? So yeah, so don't spend a lot of money on this. Get some open source solution. But before that, there are a couple of things to consider, right? So number one is purpose and placement. Why are you deploying this honeypot? What kind of attacks are you interested in? And therefore, it will define where you put it. If you are interested about internal attacks that may have bypassed your security controls or insider-related attacks, then you put it inside the organization, right? You might be interested to, say, for example, I'm interested to see if anyone is scanning my system internally, other than the legit people who are supposed to do that, like the InfoSec people or the red team or blue team. Are there any other people who are doing this, or are there any other infected machines that are doing this? So they could be the purpose, and then define your placement where you put it. Our honeypot is on the internet, right? Because it's for research purposes. Obviously, it's going to get a lot of traffic, but a honeypot inside the organization may be quieter, right? Because by right, it should not be seeing anything. But the moment it sees something, that's detection for you, right? That's bonus for you. Then type of honeypot, right? What kind of honeypots you want? It's based on what is the purpose of the honeypot. Maybe you will not see a lot of this, Linux-based malware scanning, for Telnet and SSH internally. But you may get a lot of Windows-based malware. So you may want to run different kind of honeypot like Dionia or some other ones that will capture those kind of behaviors, right? Or just a simple honeypot that will detect almost anything, for example. Then you deploy, right? Of course, deployment have to be secured and customized, right? We don't want to take risk. We don't want our honeypots to then be used to attack another system. And know for a fact that also some attackers do fingerprint honeypots, right? So they do some checking before they actually run their code and things like that. So that's how you have to customize it a bit so that it doesn't look like what's available on GitHub in terms of configuration, and people know about it. And of course, then you have to monitor it, right? Or get some data out of it somehow. There's an element of analysis as well. So this is where you want the logs, analyze it, parse it, cleaning it up. so that you can do alert or do some action in terms of incident response and so on and so forth. And last but not least, maintenance, right? Where you have to update the host, the honeypot, do backups, in case something happens to the honeypot or you want to replace the honeypot, and so on and so forth. So the idea here that it takes time, right? So people will say, oh, it's easy to deploy. Yes, it's easy to deploy, but you must have a purpose, right? And you must have a flow where you can actually then analyze the data, use the data, correlate it with other data that you are capturing in your CM or whatever, and use that for alert action. And from time to time, have a look at the honeypot to see if it's if it's been compromised or or it's not functioning anymore. So those things are to be considered. So to relate this to our own HoneyNet project. So our purpose and placement, as I said earlier, research and alerting. We have this now a service, as I mentioned earlier, called Dash. If you're an APEN member, then you can find out more about this in our members portal. And therefore, we host all of our honeypots on the internet. It has public IP addresses, v4 and v6. Type of honeypots, the one that we choose, Cowrie, we use Dionia to a certain extent. RDP honey, we have a few more, but they're not really that active. It's more for experimental and research and testing. Deployment, we have more than one honeypot, so we use a framework called the Community Honey Network, CHN. It's an open source framework. It allows integrating multiple honeypots into a single backend for us to do then the analysis and so on. But also in our plan, we have partners deploying their own honeypots. So we don't touch those, but we somehow need to get their data out to us, right? So we have to kind of think all of that in the deployment. So if you're going to have more than one honeypots, this is something that you have to think about. How do you then connect the different honeypots for managing, for data management, visualization, analysis, and which is the next point, where how do then I get all the logs, visualize it. So you saw that I use Elasticsearch, ELK stack, the file beats, all of that. I also use Suricata. So instead of just the honeypots, I also have Suricata IDS because then it gives me some of the signatures to give me context. Because sometimes for some certain type of honeypots, it's not really clear what kind of attack was executed on the honeypot, other than, I see the port number, I see some attempt to connect, but it's not really clear what the traffic, what the source was actually trying to do. But with an IDS like Suricata or Snort or Zeek, for example, you get the signatures, right? So, you can see here that attack on port 80 was going after the DVR. So probably an application to execute shell on it. So I have context, right? Which then I can do some analysis. In the back end, I also have ElastAlert because I don't just want people to go to the portal every time they need something. Of course, they can use API and whatnot, but I use something called ElastAlert so that, if you give me your AS number, I can send it to your Slack channel. Then you can process it in your back end. So you may want to have something like that as well that helps you with automation, make tickets or, alert certain people to take action from the data. And of course, maintenance, monitoring, Ansible, and a lot of manual work as well, scripting, and I use LibreNMS to monitor my infrastructure as well, right? So if you're interested, then, these are the things that you kind of have to think about. I have an example of a Slack post to a group here. So that's kind of have to be designed. So yeah, so this is kind of the overall back end. Again, fancy network diagram here, right? So a bunch of honeypots talking to different frameworks. Everything is sent to Logstash, file beats, and then it'll send to Elasticsearch, Kibana, ElastAlert, kind of the big picture, right? Of course, if you only have one honeypot, you don't have to, to do this as an overkill. But basically from the data, the whole idea is that we can, understand what is really going on. For example, this IP address that we see in our honeypot, when we're talking to the operator, we're like, this is not new, right? The fact that we see it on our honeypot, it means that other people have seen it as well somewhere, right? So this particular IP address, if you check, abuse IPDB, then you can see that, hey, this activity, yes, it was seen on 16th of October, but since November 2019, there was some suspicious or malicious activity coming from it. It was quiet for a while, but now it is back active, right? So this is not new. So this is something that we also try to educate folks that, yes, we have all this data, but then you have to do some analysis in the back end. You have to use some tools as well for pulling information from different places that will help you to further understand what is really going on here. And if you use, Shodan, for example, it will tell you exactly that on this IP address, there is a DNS and a web application. And the DNS is misconfigured for sure because it has recursion enabled, which means that it can be used for an amplification attack. But also it's got a web interface, which looks very not secure, right? Maybe default password of whatever this thing is, right? So all the information is there, but somehow, we're not getting this information to people, and people with information do not know what else to do with it. So I guess this could be saved for some other time, but there's a lot of other interesting indicators that we can get from the honeypots. If you guys are interested to participate in our project, feel free to reach out to me, because we need some help, with folks looking at the data, doing some analysis, and beyond deploying honeypots, there are other interesting data that we can actually look at. So my last slide here is, so we talk about honeypots, we talk about suspicious activities, but I think the bottom line is there's huge challenge in defending the network and also disrupting malicious activities, right? We are not doing anything that is making things harder for the attacker, right? It seems that they are able to execute whatever they want to do quite easily, as we have seen from the honeypots. And I guess the question will be, for enterprises and operators, right? How do you deal with all these vulnerable devices? How do we fix them quickly? In some cases, they will say, oh, we don't have resources. But then, how are we going to deal with this? If no one wants to deal with it, we have notified our customers, but that excuse. So yeah. So what do we do about it, right? So we have to come together to think about this. At the enterprise level, I think it's a lot easier for policy and enforcement, but the challenge has been, as I said earlier, now that people are working from home, how do we defend beyond the perimeter, right? How do you get that visibility? A honeypot will not be the solution here, but I'm just getting people to think about, what can we do for policy and enforcing those policies in place. And since we have the honeypots, I thought maybe I'd offer, if you guys need PCAPs or IDS alerts or URL or malware samples, just reach out to me. And last but not least, if you need more information, check out our website or you can let me know. So I think I still have a few minutes for Q&A. Sorry to talk for too long, but yeah, feel free to ask questions.
Hi, Adli. Thank you so much. It was an amazing session. I mean, we couldn't ask you for more. You started off with an introduction to honeypots, the project that you've been involved from 2007, from the time you've been with MyCert. You spoke a few things about MISP and threat sharing platforms. Then we spoke about Kibana, Slack, Elasticsearch, Beats, and etc. Then we saw about ports, like ports being open and like Telnet, SSH, and weak authentication, and how people could crack those things. We spoke a little bit of crypto miners. We spoke about Kauri, the open source honeypot tool, which was interesting to know. Cryptojacking, coin mining, and also you did mention about logs. Sometimes we have things in hands, but we don't see. So is it visible or we not look into? Very interesting, because that's something that though we have things in place, sometimes we don't have the habit of going and checking, making sure that, okay, are we monitoring our traffic, or do we see anything suspicious? We don't until we encounter an incident. And also finally speaking to us about running our own honeypot and what we could do, what APEN is being actively involved. So overall, it's been great. Thank you so much. And I think we have one or two questions.
Yeah.
So the first one for you is, what are the honeypots that emulate the database environment?
There are some. I can't remember on the top of my head, but there are a few that I've seen before. I think there was some honeypots for Elasticsearch, and then I've seen some for MongoDB and a few other things. I see a lot of attacks going after MySQL and MS SQL. That's like a daily thing that we see in our honeypots using Dionia. So it can actually pick up attacks targeting MS SQL and MySQL. So there are, right? Drop me an email. Maybe I can share you the links if you're not able to find it. Yes, I'm reading the question as well.
Yeah.
Someone asked me privately, but I think I can share this.
Sure.
So the tools are open source and free. How do we know if it's safe to use open source tools? Yeah, so I think that's the thing. You trust, but you verify, right? So again, looking at the source code, a lot of the tools, the source code is wide open, so you know that it's not sending data to to certain places. The code also, there's no guarantee that it's secure 100%. So again, you have to consider that as well. So don't run things as root, for example. If the honeypot is compromised, your whole box will be compromised as well. The other thing is then you can engage with the developer. And that's the beauty of doing a lot of work with open source tools. The developers are actually still alive, and they can be reachable on GitHub, and you can chat with them on Twitter or Slack or whatever. So there's an opportunity to go beyond just using, but you can actually know the person, which then can tell you, hey, I can actually trust this code, and then you can deploy it. So think about that as well. Some folks are asking about a presentation. I think I will share this with the organizer, as well as if you want to send me an email, I'm happy to send a link where you can download the slides as well.
Thank you, Adli. I think that is all the questions we have.
Yeah.
So thank you so much, Adli. It's once again on behalf of Sri Lanka Cert, let me thank you for taking your time to be with us today. I know it's virtually, but it has been a great session. Thank you so much, and hope to have you in our future sessions too. Thank you.
All right. Always a pleasure. Have fun, everybody. Thank you.
Thank you. Guys, so that's the end of day 2. So we've had 2 sessions today, one about ATM frauds on RISE, and then we had again Adli's session this afternoon. So we have 2 sessions again tomorrow, same time, 10 to 11 and 2 to 3. So one is from Director TRC, who's going to speak about on impact of the telecommunication network on network security, which is 10 to 11. Then we have Eng Chun from ST Electronics. Is going to talk to us on cyber threats during COVID-19. So again, interesting topics to look for. Let me also thank our sponsors, Cisco, SLT, Mobitel, Dialog, for giving us a platform and making things easy. Let me also thank Soteria for giving us, who would be giving us the platform for the hacking challenge. So thank you so much. And I hope to see you guys again tomorrow. Thank you so much. Thank you. Bye-bye.